Brandon. Come on over, get a seat. We've got an awesome meetup ready for you guys tonight. Who's excited to hear from Zeppelin? Yeah! Awesome. Who's excited to hear from Oracles? Yeah! We got a few more little pictures scattered in between for you. My name is Zane Witherspoon. And we are the San Francisco Ethereum Meetup. So thank you so much for coming out. We really appreciate the support. We have a ton of pizzas there in the back, so please keep going back for seconds and thirds and however much more you want. At the end, we might have some pizzas to take home for some lucky winners. We've got, like I said, an awesome presentation for you guys. I would like to just take a second, first of all, and talk about our meetup. So, we are the San Francisco Ethereum Meetup. We've been doing events for how long? 6 months. Right around like 6 months, yeah. So, we're super excited that this community has grown so much. I think this might be our biggest event ever. So, we have people to thank for that too. Let's give a big round of applause for our venue sponsor, Runway. Yeah! You guys are great. This is such an awesome space, and it's so kind of you to share it with us. Thank you, Courtney. Thank you, Joe. Also, the people who are feeding you, drinking you. Let's give it up for both Zeppelin and Oracles for donating. Thank you, sponsors. So, we've got some awesome presentations. We're very excited to have all of you here excited about this like we are. It's so cool to see our community growing. If you feel connected to this community like we do, then let us know because there are opportunities to help us grow. If you feel like sponsoring a meetup or sharing knowledge or
if you have a project that you're really excited about and you want to tell people about,
Yeah, there's lots of ways we can help build this community together, and it takes a lot of people. It takes a lot of helping hands. We've got some great volunteers here tonight. Let's give it up for our volunteers. Honestly, That's really going to happen. We got a few QR codes scattered around with Ethereum addresses. If you feel compelled, then you can go ahead and shoot us a donation. Otherwise, go ahead and track one of us down if you've got some bigger, more broad plans. Let's just start out by gauging this crowd. I see a lot of familiar faces, which is awesome. It means this community is growing bigger and bigger. And a lot of new faces, too. So how many people here is this their first Ethereum meetup? Whoa, nice.
Give it up for the people who's their first time coming to Ethereum.
The community gets that much stronger when everybody comes together. So, how many people here own Ethereum? How many people are happy about Bitcoin right now? Yeah, that's an exciting one. How many people here are developers? Oh, wow. Is that a crowd like that? Nice. How many people here have used a Zeppelin contract before? Alright, we're hearing some. How many people here have participated in an ICO? You'll be receiving a call from the SEC shortly. You're good. Alright, cool. So thank you so much everyone for coming out. I think we're going to jump into the presentations. The Zeppelin team will be going first. So, if you would all come together and let's give a big round of applause to Manuel from Zeppelin.
Thank you, Zane. Hello, everyone. We get somehow.
We got slides coming.
There we are. Spoiler. So thank you for inviting us here. I'm happy to be in SF. Happy to be here. So I will talk about the evolution of the smart contract security and development ecosystem in the past year. feel free to stop me at any time. I gave this same presentation at DevCon, but this is a meetup, so we should probably make it more interactive. If you have any questions in the middle, you can just stop me and we can review anything in more detail. Animation.
All right, yeah, we'll get our rhythm worked out.
Oh yeah, you can
Yeah,
come forward. So for those of you who don't know Zeppelin, we are a smart contract security firm. We're most known for doing audits. We also build tools and technology to make smart contract development easier and more secure. We have Open Zeppelin, which is a smart contract framework in Solidity, and other products we're working on. So the talk will be divided into 3 sections. First, I'm going to review the past year in smart contract security. Then I'm going to talk about new security patterns and techniques we've been seeing in the wild, which I think should be more people should be looking at them. And finally, I'm going to talk about some pending challenges and see into some ideas on how to solve them. So let's start with history, the Dark Ages. So 2016 was a pretty dark year for smart contract security. We've seen some pretty embarrassing hacks, most of which you probably don't remember at this time, except for the DAO. But just to get a sense of how the industry was back then, we're going to focus on one specific example, which is called Rubik's. So Rubik's was a pyramid scheme formalized in a smart contract. Apparently, the developer didn't think the original name was Dynamic Pyramid, but the developer didn't think that was a very good name. So we, at the last minute, decided to change the name to Rubik's, which is more shiny. But unfortunately for him, he forgot to rename the constructor. And after today's events, you probably know what happened here. It was everywhere. But if you change the name of a contract and don't change the name of the constructor, this makes the old constructor automatically become a public function. So anyone could. Oh, we don't have the GIF animation. Never mind. It was a funny GIF. So anyone could call this function and become the owner of the contract, and this would allow them to steal fees from the contract. So this is like a pretty pretty amateur mistake, but the same feature in Solidity probably caused the parity wallet hack from some months ago. And actually, the one happening today, I don't know how many of you saw that. But, so the industry was pretty bad at the moment, and some problems are still carrying on today. In May 2016, Peter Senez wrote a great article calling the community to gather around building software and engineering practices for smart contract security. And 1 month later, the DAO hack occurred, which was the biggest hack to date. Roughly 14% of all ETH tokens were held by a single contract, which was crazy. And around $50 million were lost to a hacker that found a reentrancy bug in one of the functions of the code. Unfortunately, back at the time, the only solution for this bug was to hard fork the underlying platform, which brought lots of other complications and security risks. Actually, the first implementation of the fix was a soft fork, and it was later found to break Ethereum, so they had to do a hard fork. So it brought lots of complications. So, but by this time, everyone was pretty aware that we needed to ramp up our security practices. So we launched Open Zeppelin, which is an open source framework and community effort to learn more about smart contract security, develop reusable modules that you can throw into your own project and start with a solid base, and also talk about security practices. And 1 week later, I traveled to Shanghai for DevCon 2, and everyone loved the idea and everyone wanted to help. It was sort of the first initiative towards these goals. And since then, the framework has been growing a lot. We've had like more than 8% week-over-week growth for more than 3 months now. We have lots of community members. This is a hockey stick. But the truth is that we built something that was really needed just in time for when the Ethereum communities blew up. So we gathered lots of new developers that were learning the language. And so apart from the community building better tools, Ethereum as a platform evolved a lot too. We've seen the consolidation of standards such as the ERC20 standard, which is now an EIP for token specification and interoperability. Ethereum also fixed one pretty nasty security problem which was called the cost stack attack with EIP 150. And Solidity, which is the most popular smart contract language, also got some cool new upgrades in terms of security. These are 6 new keywords. I will briefly go through them. Payable allows to control when our contract can or cannot receive money. Require and assert are ways to specify preconditions and postconditions for our functions, which are really useful for security. Transfer is a safer way to send funds from a contract. Revert is a way to cancel execution of a function without wasting all the gas in the transaction. And pure and view are the successors of the constant keyword, which basically specify if a function can or cannot read or write state on the contract. So all these are really useful for writing more secure smart contracts. Another update from this year is that the Serpent language died or was deprecated. We did a security audit for the Augur team where we audited the Serpent compiler and we found eight critical security vulnerabilities, which led us to find a vulnerability in their rep token code, which enabled any attacker to freeze the contract for indefinitely. So we worked on them with them on migrating the token to Solidity and doing the data migration, which was a pain in the ass, to be honest. But after that, Serpent was deprecated by Vitalik with one tweet, which was like that. So more recently, the Byzantium hard fork brought some interesting features for security too. Addition of big integer modular exponentiation, which enables RSA signature verification. The addition of the static call opcode, which enables safer calls to untrusted or unknown contracts, because it doesn't allow them to modify our contract state. And the addition of the opcodes for handling return data and the revert opcode enable more flexible ways of implementing upgradability proxies, which is another interesting thing in smart contract security. So that's a summary of what happened in the past year. I will now talk about some new patterns and techniques we've seen in the space that are useful for improving the security when developing smart contracts. So let's say you're a developer learning Solidity. So you want to create your own token, which is the new thing right now. With Open Zeppelin, you can do this with 10 lines of code, as you can see here. So you decide to add a new feature to make your experiment more interesting. So let's say that just for fun you want to add a locking functionality to your token where users can lock funds, a certain amount of funds for a certain amount of time in the future. A way you could implement this is by adding an extra lock function to the code and then altering the standard transfer methods to respect these new restrictions you're adding. So let's see that in code. I don't know if you can read the code from there, but this is the lock function in which you specify the beneficiary of the tokens, the amount of tokens you want to lock, and the amount of time you want to lock them for. And this simply transfers the tokens immediately, but then stores in a log array for that beneficiary the amount of tokens that are locked until which moment in time. And then we override the standard transfer functions by adding an additional function modifier, can transfer, which specifies the amount of tokens transferable for that address at that point in time. And to implement this logic, we just iterate over the array of logs for that address, add up the amount of locked tokens at this moment, and then return the total balance minus the amount of locked tokens. So, hand raised. Very good.
Like, let's say you have, I don't know, just 100 people that have blocks. How much gas does that cost to run that?
Very nice.
Could you please repeat the question for people in the back and people watching online?
Sure. So the question was, what happens if 100 other users create blocks for one account? What happens with the gas costs of iterating this array? And you're very intelligent. That was exactly the puzzle here. I was going to say, if you go forward, this seems like it implements the feature correctly, but there's a catch, and that is the catch. Here was when I was going to ask, can you spot the problem? He already did. So that's great. This is a great community. The problem is we have a gassy array, which means to explain this, can you stay there first? To explain this for the others, the problem with having this function iterate over the array is that the length of the array can be controlled by any attacker just by calling the log function many times with small amounts of tokens. So for those of you that don't know, every Ethereum transaction has a gas cost that depends on the amount of operations that are executed in that transaction. And to iterate an array, the longer it is, the more gas it will consume. And anyone can just keep adding logs to your address, making the gas cost of executing a transfer super high. And given that there is a max amount of gas that can be spent in an Ethereum block, which at the moment is 6.7 million approximately, it can make like a denial of service to an address, making it impossible to transfer tokens. So this seemed like a really simple feature to add, but it's actually making the token vulnerable to an attack. A simple fix for this would be to add a limit to the amount of tokens, the amount of logs per address. But I wanted to show you another way to think about adding features to tokens, which I think is more interesting. The basic idea is, instead of modifying the token code and adding the log function, you just leave the token as is and implementing the new feature as a separate contract, so that when a user wants to lock tokens for another user, they just instantiate this new token time lock contract specifying the beneficiary of the tokens and the release time, just as before, but in a separate contract. And the user sends the token to this new contract. So the extra functionality is implemented by a separate contract. And to lock tokens, users have to opt in to creating this new contract and sending the money. So in this way, as you can see, this vulnerability was fixed because we don't have any for loops or any arrays. But just in general, if you think that any vulnerability that could be found in the locking functionality has no way of affecting the original token transfer. So it's a way to add more features without increasing the attack surface of your contract. So the point here is, every time you add a feature to your smart contract, bear in mind that you're expanding the attack surface and you're adding risk to other users. Just as another example, at the beginning of the year, most crowd sales were implemented inside the token code, which, if you think, it's a really bad idea because you are reserving some bytecode and you're keeping the code to manage a crowd sale that's supposed to run in 2 weeks, and you keep that code forever in the token. And right now, most crowd sales are being implemented outside of the token as a separate contract. So next, I wanted to talk about some basic software engineering practices that really help security. And most of you will, if you are a software engineer, you will think these are basic things, but not everyone is doing them, so I wanted to point them out. The first is that clear and simple code is always better. All security problems come from a difference between the intention of the programmer and what the code actually does. So if your code is easier to read and understand, it will be easier to verify that your intention is actually what the code is doing. A corollary of this is that naming matters. Also, you should reuse existing audited code. There's no benefit in re-implementing stuff that has already been implemented and audited. You can't imagine how many times we audited re-implementations of the standard ERC20 token, which is very boring to do, by the way. Also, if you're reusing code, try to not copy-paste the code into your code base and just import the dependency, because if there's a bug fix in the original code, you won't get the update. Also, don't repeat yourself, which brings lots of problems when you're modifying the code. And write tests, which is the easiest way to verify that your intentions for the code are what the code actually does. So, to repeat what I already said, these are really basic software engineering practices that every developer should be doing, but especially with Ethereum, your code is managing real money, so you should be really focusing on following software engineering practices to protect your code from ninja hackers, dumb users. We have a question. And other developers.
How do you think about the risk of when you have like third-party libraries of, maybe you don't have time to audit each time someone pushes out a new version, so, in some ways you're also increasing the surface area of ways that, bugs could enter your program.
So the question was, how do you think about using third libraries? Maybe you don't have the time to audit dependencies you're using. So the question is basically, what are the drawbacks of using third-party code? That's a really good point. That's why I say reuse audited code that's existing out there. It doesn't make sense to just grab a code you found on Reddit, because it's probably not well tested and maybe it's not even deployed and used anywhere. So if you reuse code, try to reuse libraries that are audited and that have a development community around it. Just in general, about reusing code, it probably will take less time for you to audit an existing library if it's well written than to write your own implementation and to audit it yourself. And it's usually not a good idea to audit your own code, because you already have your preconceptions that you had when you wrote the code. So at least it's better if you can get someone else to look at your code if you rewrite it.
Do you have a process for bumping like versions for dependencies? Like, how do you know that each version is really getting audited?
Yeah, that's an ongoing discussion in the community right now. Like the question was, how do you manage versions of the code, and do you audit every version? How do you know which version is audited? There's no really standard package manager or code distribution solution at the moment. There was an initiative called ETHPM for distributing code. It didn't catch up because it was very buggy. But at DevCon last week, I was talking with other developers about reopening the discussion on dependencies and code versions. So this industry is very new. Other question back there.
Yeah, how do you deal with like potential compiler bugs? I know that Solidity is a new compiler, and there's been various issues. And do you think that there's other issues that are outstanding with Solidity that haven't been discovered yet? And then how would you go about? Would you audit the bytecode, or you doing at that level, or what are your thoughts on that?
So the question was, how do you deal with compiler bugs? And that's a very big problem in the space, especially like since we did the audit for Serpent, which was the second most popular language, and we found lots and lots of bugs. And we did that. We looked at the generated bytecode and all the compiling toolchain and funnel. And Solidity has, I think, some teams are auditing Solidity now, but that's a real concern. And given that most projects are using Solidity right now, there's a big risk in centralization of tools, because if there's a really big bug in Solidity, most code deployed has been compiled from Solidity, so it's a big risk for the whole ecosystem. Should we? Yeah. So another question back here. The question was, how did we come up with the name Zeppelin? The answer to that is, we really like the Led Zeppelin band, and we also think Zeppelin is a really good word. We like the Z and the double Z. And it's also, we see it as a kind of weird vehicle to getting to cool places, and we see smart contracts as a weird technology that will get us to cool places. So, moving on. You can still interrupt me for questions. So I wanted to briefly talk about the relation between trust reduction and security. Let's say you are a freelance Solidity developer working for a client that requested you code a capped crowd sale. So you write this simple code, but then he comes and says, oh, please add some tokens for the foundation when the crowd sale is finished. So you go, sure, boss, I'll do that. So you go back to the code, and the change is really simple. You add the ownable dependency to your contract, which makes the crowd sale owned by an address, and then you add a finalize function, which is the not yet. If the cap is reached, is there any way I can do the switching?
Press the button.
Is it okay if I? It's probably better for humoristic reasons. Let me try.
The arrow.
Down arrow.
Yeah, just the sideways arrows, the arrows.
Yeah, no, I'm trying to get this full screen. Well, whatever, let's continue. So you have the finalize function, which if the cap is reached, will mean new tokens for the foundation. But when your client sees this, he goes, oh no, but make it trustless. I don't want to have a special account owning the crowd sale. I want it to be totally trustless, which is something we hear a lot in this space. Like, we should always make everything as trustless as possible. So, oh no. There we go. So you go back to your code, remove the ownable dependency, and just stick the same function code inside the token purchase function, so that when the last investor sends the money to the crowd sale, the finalization logic is executed, and the new tokens are minted for the foundation. The problem with this is you inadvertently added a vulnerability to the code, because if you check this, if an investor sends a transaction with a value of 0, the code will still execute. There are no checks for that. So if the cap is reached, any investor can continue sending transactions and minting new tokens again and again for the foundation, ruining the crowd sale, which will be a disaster. So the point here is, it's not always better to make your contracts more trustless. It's sometimes okay to reduce trustlessness to increase security. If you think about it, moving such critical functionality as minting the tokens for the foundation, which is something that's only done once at the end of the crowd sale, it makes no sense to leave that in the hands of just the last investor who you don't really know who will be. For really critical parts of the code, it's better just to keep that in the hands of the owners of the contract or the developers of the contract, because you have more control and you reduce the attack surface of your contract, because only the owner can call that function. And I'll go back for a second. If you check the original version, that still has the same bug. If the owner calls the finalized function again and again, they can still generate more tokens for the foundation. But if you leave this in the hands of the public, they will most probably do it if they find it just for fun or because they can. As we maybe saw today when someone, well, never mind, too soon. So let's move on. Finally, oh nice.
See if that works.
Let's see.
Hey.
Awesome.
Cool.
So let's try it again.
Technology.
Thank you. So what is that?
It's a great
Oh
question.
no. Well, you'll find out at the end. So some open problems in smart contract development and security. The biggest ones are these four. One is upgradability, which is once you deploy a contract to the blockchain, there's no way to change it by default. Like an open problem is how to do code upgradability so that you can fix bugs and add new features after you deploy them and are already in production. The second one is interoperability, that is how contracts can connect to each other and interact. Third one is the gas costs of these interactions. The fourth is code duplication in the blockchain, which means when people reuse code and deploy their contracts, they are deploying copies of the same code again and again, and that's very wasteful. So we have a new project called Zeppelin OS, which tackles all these problems, and I want to briefly tell you how we call this. This is bad. So there we go. So as for code duplication, one of the components we are thinking for Zeppelin OS is what we call the kernel, which is basically taking what we already have in Open Zeppelin as a GitHub repo and migrating that into an on-chain library that lives as a contract in the blockchain. This will make deploying applications more efficient because contracts don't need to redeploy the same code every time they use these dependencies. So this is for very core pieces of code like token code or browser code that is reused again and again. And this same kernel will have an on-chain upgradability mechanism so that if someone in the community finds a bug in the code, they can propose an upgrade to the kernel and fix the code on-chain, and everyone using the kernel and the OS in the blockchain will get the fix for free. If you think about this for 2 seconds, you will realize that it's a security risk if you leave these upgrades in the hands of a central organization, because if hundreds of projects are managing lots of money, lots of funds on top of the OS, and any single organization has the power to change the code, there's a risk that they can change it maliciously and steal funds or break already existing contracts. So we also designed a governance mechanism where anyone can propose upgrades and the community can signal which version that they are using, and also incentivizing development over the most popular versions by providing bounties to developers that do this development. And the technical foundations of these ideas were developed alongside with the Aragon team, which are friends. So they are also using the same ideas in their own Aragon OS. If you want to see this in action, you can check their projects too. So next, two other components of the OS are questionnaire.
Can we use the same governance mechanism in our own contracts?
The question is if we can use the same governance mechanism in other application contracts, and the answer is yes. That's part of the set of libraries that we provide as the kernel, like the upgradability mechanism for application contracts too. So scheduler and the marketplace solve the other problems I was describing earlier. I need to explain this problem first because it's something that not many people are thinking about now. So we think that smart contract technology has more potential than what we see now, and that will be realized when contracts start interacting with each other. We don't see many interactions between contracts right now, but to give an example, one case we do see at the moment is a multi-sig wallet, so a multi-signature wallet controlling another contract for authentication purposes. So 3 out of 5 wallets controlling a crowd sale and deciding which methods can be called by that wallet. And if you think about how the interaction works, when the first owner of the multisig proposes a new operation, this is recorded in the multisig contract. Then when the second owner signs the transaction, the multisig contract records this. And when the third signer signs it off, the multisig does the operation on the crowd sale contract in the same transaction that the third signer is approving. So it's all in the context of one transaction. And all the gas costs of executing the multisig operation are paid by the third owner. So this is kind of unfair, and it's also not very flexible if you want to create more complex interactions. So the scheduler is a component that allows smart contracts to request future execution. So this enables, for example, in the case of the multisig, when the third signer signs off the transaction, the multisig could request a future operation in the future. So anyone, not necessarily one of the owners of the multisig, can come back and pay the gas cost and do the execution. And it also enables other sort of asynchronous programming for smart contracts, which at the moment are not possible. And the marketplace is simply standards to enable contract-to-contract interaction, which means tools to specify how contracts can expose their services and request payment for their services in say, I want to be paid per call this amount of money, or I want to be paid a one-time fee or a monthly fee. So that's the marketplace. And finally, we're going to create a set of off-chain tools, which we call the Smart Contract SDK, which are CLI tools for developers and web applications to manage, deploy, and control contracts once they are in production, so that you don't have to do everything on the command line. So this is Zeppelin OS. You can check more about it online. I will skip this. That's all. Thank you for your time.
Thank you so much, Manuel. That was amazing. Let's give it up one more time. Thank you for coming to speak, and thank you for letting me DJ your pool party in Cancun. It was a real DJ. Actually, it was actually like so much fun down there at DEF CON. These guys were killing it. It was an awesome time. I think it was Manuel spoke down at DEF CON just like a few days ago. It was Manuel, right? Yeah. So, awesome. That was Zeppelin. So, we're excited. Right now, we've got a few micro pitches coming up, and then we're going to hear from Oracle Network. If you if you're still feeling hungry, definitely get more pizza because there's a lot to go through. Alright. Matt, who we got up next?
Alright. Refer to the deck. First is experty.io.
Alright, guys. We've got a series of 60-second pitches. So we're going to come up and everybody's going to talk about what they're working on right now. So, experty.io, if you can step on up. Okay. Sarah, it's great to meet you, I'm saying. Go ahead and tell us what experty.io is all about.
Okay, awesome. Thank you guys for having me. So basically, Expertise is a Skype-like app. It allows you to voice and do video consultations, and you actually get paid instantly. So think about all the times you're sitting home, you have a lot of free time, and you want to monetize your knowledge somehow. So how do you do it? You actually use our platform, sign up, very easy. And for example, if you're a doctor, an attorney, a programmer, someone needs help solving a problem, and you have that expertise, they actually call you up using our platform, and you get instantly paid using our tokens. Is that good?
Yeah, that's it.
Is that enough time?
20 seconds to do
So much.
So that's it.
Matt's just really excited to hit the buzzer on something.
Thank you. Give it up for Sarah.
Thank you guys. And you can check out our website too.
Experty.io. Go ahead and give it a shout. Cool. Next up, we've got MetaSwarm. Luzelle. Let's see, where you at? Luzelle. Yeah, we go. Alright. You about good?
Yeah, we're just going to zoom in a little bit.
Just doing some zooming. Here you go. Why don't you step on up here? Neerj. My bad. Sorry. Neerj. Why don't you tell us all about Luzelle?
Alright, so I'm going to try to make this quick. I'm CTO of Luzelle Networks. We started the company in Canada in 2014, moved to Singapore in 2016, and we've been doing enterprise development ever since. One of the things we really realized is the blockchain is a terrible database. It's really good for writing applications. Ethereum is terrific. A lot of people have already spoken about writing applications in it, but for database, it's really not a great database. So what we actually have been solving is a problem, writing a database that's decentralized, so that if you're writing applications in Ethereum, you actually have a database to use. So this is our database. It's a metaswarm. What does that mean? It's a collection of swarms. You take your data, it's all split up into these swarms, sharding, which is actually the scalability solution that Ethereum is planning to use in the future. And it's a cryptoeconomic model, so that if you want to participate in the network, you can be a farmer, you run one of these nodes in the swarms, or you can use the database as a consumer being a developer. Store your data into the database, use your tokens. So we're actually going to be doing a token sale probably later this year, first quarter of 2018, we haven't decided. And you'll be able to use these tokens, earn these tokens, participate in this network. It's the three key technologies we're focusing on are performance, scalability, and reliability. You have your data spread out around these swarms, and of course, if a node goes down in a swarm, your data persists. So definitely check us out. We're on Telegram and we're on Slack. And afterwards, if you want to get one of these T-shirts, just come up to me and answer who these guys are. Thank you.
Thank you. All right. We've got one more presenter for you.
Blockchain with the best.
Blockchain with the best. All right. This is Alex. Alex, it's nice to meet you, man. Thank you to meet you. Why don't you tell us all about what makes blockchain with the best in blockchain?
Hi guys. Yes, I'm pretty new to the blockchain. I've been like 9 months in, and I was trying to learn everything I could about it. So one way to do it for me was to organize this conference. So it's going to happen next week on the 15th and the 16th. It's an online conference, so you can attend it from home, from work, from wherever, either online or via replays. So we gather 50 speakers. It's going to be 2 tracks, one for developers and one for with general topics. So some of the keynote speakers we have Tim Draper, we have Davin Simstebo, who has developed IOTA, we have Patrick Dye, who has developed Kenton, We have AI Liatok, who has developed Bancor, and tons of stations covering different industries, from the healthcare or even democracy with big nations. So a lot of stuff. If you need a promo code, I'll post a promo code for you free to test.
Reggae horn.
Awesome, thank you, Alex.
One more, one more.
We got this conference coming up.
Gaia.
Next up, we've got Daya. We're talking about Beef and his Ethereum payment system. And he's got a live demo working for us. A product before an ICO, or what in the world is it?
Great, good to see everyone here. So I've got a live demo here. So what I've done is I've built a blockchain payment system. So I know you can't see this right here on the screen, but I'm going to give you a quick demo. So what this is really an extension of the back end. I built a POS system. So like you would go into a store and you would order something, for example, French fries or garlic fries, and you would pay. Sorry. And a QR code gets generated. And the user would open up the app and they would scan it. Okay. And then they get the amount, $2.50, whatever it is. They would pay. And you see the transaction.
Everybody give it up for Daya, the POS system.
That was me. Hello? Test? There we go. That was me. That was me. Thanks so good. Hey there, everybody in the back. I'm glad you guys are enjoying the pizza and beer. Good job, good job. So we've got, we're sort of wrapping things up. We've got Igor ready to talk about Oracle networks. If you can hear me, clap once. If you can hear me, clap twice. If you can hear me, clap 3 times. If you can hear me, clap 4 times. If you can hear me, Manuel, this means you too. Awesome. Just take 1 second to talk about what I'm working on. I'm Zane Witherspoon, the CTO of Dispatch Labs under the Bureau Incubator. We are working on building a business-ready blockchain. We are building a blockchain from scratch. If you're a developer and interested in protocols or security and scalability solutions, you think things could be better than they are right now in the world of blockchain and tech, come talk to me, because we are looking to hire developers. I am the CTO. I'm so excited to share my white paper with you, talk to you guys about all the exciting developments and delegated proof of stake and stupid hash tables and all that really nerdy stuff. So come track me down afterwards if you've got any interest in that field. Alright, so now we're going to hand the mic over to Igor. So if I can get your attention, please, over there in the back. I still hear you. Alright, cool. Thank you guys. Yeah, here's Igor with Oracle Zeppelin. Thank you.
Hi guys, my name is Igor Barzov from Oracle Network. I will present about our tool called ICO Wizard. First, I would like to explain what we are doing. So we are a network based on the Ethereum protocol with a consensus called proof of authority. So it's in a simple form of proof of stake with identity as a stake. So usually in proof of stake systems, validators put some points on stake and a penalty mechanism. But we decided to reuse existing trust mechanism, and we have independent validators as validators in this network. As you can see, we have some requirements for validators. They have to be independent and non-affiliated with each other. We use US public dollars as validators. It means that their identity can be publicly verified. And we have some procedures how how they validate their identity, and we put this identity on chain, and because this part of identity also exists on governmental services, and you can serve third party can cross-validate identity on chain and on governmental websites. We have so our chain is easily scalable. We can create additional instances of this chain with the same set of validators or with different sets of validators. Right now, in our set of public notaries, we also have a subset of attorneys, a subset of CPAs. So if, later on we can create a different set of validators for different networks. And we utilize an idea of cross-chain transactions, so all networks will be connected to each other in trust is free. When you have POA, proof of authority-based network, it's technically simple to build a bridge. Between two networks, and if you trust to POA network, it means that you trust the bridge between two networks. Yeah, so we were doing ICO like many crypto projects, and you know, when you look into repositories of successful ICO, you can find code, and this code usually audited, and you know, it's used by this ICO, and usually successfully used, right? But if you would like to try to use it for your project, you need lots of skills, and we decided to build a tool where you can, you know, reuse someone else's ideas and create your ICO without, you know, expensive coding and customization skills. And we had several ideas in mind. So first of all, this tool should be, you know, client-side without backend. So all you use, you can validate what's inside. And it should be open source, so anyone can contribute, can participate in this project. It should be free, so we don't take any commission. Not like other projects. And this tool should follow some rules described in the previous talk, like modularity, interoperability, and so forth. So our tool allows to create token accounts at one checks on any Ethereum network, and that it follows one strategy, so-called mintable token. And some stats for about our research. So I started 4 months ago Silicon Valley Ethereum meetup as like a toy project when I did presentation about the ERC20 tokens for our community. Right now we have 8 contributors from different countries, most of them from Argentina and US. So it's built on, we took as our main library, token market library. And we had some new features like multiple tiers, which are not supported by token market library. We had whitelist, which is a modern way of creating ICOs nowadays. We have updatable tiers, which is a strategy that some people don't like, but it's good for people who are not sure how their account sale will be in the future. We have some production ICOs run on this tool, and I do not recommend to use it, right, because it's not audited by external team. Yeah, but if you, let's say, if you would like to use it, I can personally share 50% of your expenses, because it's also interesting to me, right? So there are some projects, I want to mention one. This is a guy, he's a developer from upstate New York. And he built this. He built his crowd sale using ICO Wizard, and people invested about $200,000 into his ICO. You can see he moved most of his funds. He moving, from wallet to wallet. But you can see here, in one of his wallets, he has $162,000, and this is a team of one guy. One developer. He wrote his white paper himself, and well, not a good quality, but still a white paper. And he's a team of one. And now he has $200,000, so he can start this new project. And next I'd like to show you how this ICO wizard works. And I would like to show two scenarios. So one scenario is how people actually use it now. It's like what it is now. And second is kind of the future. And the future we would like to see. It's called cross-chain crowd sales. When crowd sale contract located on one network and token contract located on another network. So it's our approach to scalability. But let's start from ICO wizard. First step. So usually we have 5 simple steps. On the first step we specify token name and ticker and how many decimals it should be. We can specify reserve tokens. If you remember from previous presentation, here you don't need to vote. You can just select multi-sig wallet of foundation account and add let's say 10% of raised funds into foundation, and let's say to one another contributor. We can add some fixed amount of tokens, as let's say it's a bounty, let's say 1,000 tokens. So this is the first step. It's when we configure a token contract. On the second step, we configure a crowd sale contract. Usually we have to put wallet address. And there's a block, and this block corresponds to a tier. So tier is a logical step of your crowd sale. We can have multiple tiers. Think about it as pre-ICO, ICO stage 1, where you have bonus 30%, ICO stage 2, where you have bonus of 20%, and so forth. So you can configure start time. In this scenario, it's tomorrow. So let's set it up to today in 5. So we'll be able to buy. And we can specify rate, how many tokens we'll get for one user, and total supply of this token, and the validation for each field. We can make this tier updatable. So if tier is updatable, it means that owner of this smart contract can later modify some parameters like start time, end time, rate, and supply. So if you are not sure, you can use it. And also by default, we have whitelist disabled, but you can enable it, and you can enable for each address. You can enable minimal and maximum amount of contribution, or only minimal. But by default, I will turn it off. And that's it. After you have to sign some transactions. Right now there is no, I don't know how to make it. There is no so-called bundle transaction, so we have to sign transaction. So I cannot send like 14 transactions. So I send some transaction to create individual parts of crowd sale token, and also I modify this contract with parameters. And you can see on the background we have a page where you have all information about created contracts, and you can download source code for all contracts and use it for audit. Well, we figure out that it's very hard for auditors to audit this type of code because it's kind of generated by computer, and it's not the way how they like to accept this type of code. So we are working on this. We will have next release. We will have some structure of download files, so you can get individual file with the order of how each contract is created, and the all contracts will be in separate files. Because first time we sent it to, well, not we, but the user of our wizard sent it to external auditor, and they sent just a file with 150 kilobytes of code without any explanation of what's inside, and it was kind of hard to understand. And yeah, we're almost here. It's 12 transactions for one tier crowd sale, and well, it takes much less time to send this transaction than to code it yourself. Usually to create an ICO takes about 5 to 6 minutes. Yeah, you can see here we have this large file with all contracts. And, right now it's one text file, but we split it into multiple files. Okay, now I have this information because it's already in our text file. We don't need to save it. And we have 2 pages you can bookmark. So one is like performance page of your crowd sale, where you can observe, how many investors you have, how many contributors, how's your goal, and it will update itself with when you're on different tiers. And the next page is actual invest page. On invest page, we have current account, we have investing from, token address, where's our basically token located crowd sale, which minus share ratio, and you can see name of token, ticker, and supply. And from here, as an investor, you can actually invest. Well, right now, on this page, you can invest using MetaMask or any Web3 injected wallet, but later on, you'll be able to, this week, you'll be able to invest using QR code with just regular wallet. Yeah, so that's it. We bought one token, receipts are on balance, if we switch account to let's say another account, we have different balances. So balances dependent on which account we use. So that's that easy, right? This page can be used by any participant of your crowd sale to invest. Well, I think it's awesome, right? We have 5 minutes. Thank you. That's what people use right now, and we have people who use it from many different countries. Well, if you'd like to use it, you can get support on GitHub and on our Telegram channel. And yeah, if you would like to make an external audit, or you would like to share expenses, like we pay half of this external audit for your crowd sale. That is for first people. And yeah, I'd like to show you next page. In MetaMask, yeah. So this is called cross-chain crowd sale, right? It's a new concept, and in this concept we have crowd sale contract on the one network, let's say main Ethereum network, and we collect money on main Ethereum network as a project. But we create our token on another network, let's say UA-based network like Oracle's network or other cheaper network. Yeah, why it can be useful for people. Let's say this is a stats page of our POA network, and you can see we have 6 seconds block time, which is like 3 times faster than main Ethereum network, and the price of transaction on this network is like 3,000 times cheaper than the main Ethereum network. And if it became the same, we can easily create another instance of Oracle's network and with so-called trustless consensus.
The transaction we just made was on this network, right?
Yes. So the transaction we just made was on this network. Yeah, because it's very cheap. Why to use another one? And as Microsoft says, it's like eat your own dog food, right? So if we run our own network, yeah, it's good to use it. Yeah, but the problem here, let's say you're doing your crowd sale on main Ethereum network, so your tokens created on main Ethereum network, and it's hard to move them, right? For when the price will go up of computations and these resources is limited, it will be more expensive for some projects like advertising, for some real-time transactions. It became more and more expensive. I remember when I started to develop Ethereum, Ethereum price was less than $1. And I remember, sometimes I opened RPC and someone stole 80 ethers from my node, and I thought, nice, okay, I'll buy more. But now I think, it's very expensive, and it will be more and more expensive, because there is no scalability solution in the market. So that's why we decided to use this type of crowd sale for our crowd sale, and we'll collect ethers from the main Ethereum network, and we'll unlock print tokens on our network. So how it works? So we have here, as you can see here, this is the side of a bridge. So when this bridge is running, we have on the left side we have one network, on the right side we have another network. It's left and middle columns, and we have a bridge which is also decentralized. And this bridge can be usually in a review network. You have some amount of validators. Let's say in our network is 25 validators, and you can specify the bridge will sign transaction with consensus of, let's say, 5 validators from this list of 25 validators. So when someone emits an event on the left side of the bridge inside smart contract, this validators runs bridges. They observe this log events, and they create transactions on the right side of the bridge. And these transactions on the right side of the bridge, they actually modify something inside smart contract on the right side of the bridge, and if consensus is reached, let's say 5 validators out of 25 validators sign a transaction, then we create token on the right side of the bridge. And you can query list of validators from consensus level of this type of network. So if you trust the consensus of the network, you trust the list of validators, and you eventually trust the bridge. So that's why this bridge is trustless. So here we have private network. You see this private network as our Oracle's network, instance of our Oracle's network, and we have ICO wizard with this bridge feature enabled. It's deployed on this network. So when I buy one token here on the left side of the bridge, actually this contract will report an event on Oracle's network, and bridge will listen to this event, and it will create transaction on the right side of the bridge, and this transaction will create token. You see here we have private network, and we'll look into let's see. This is a smart contract on the right side of the bridge, so-called token contract, and this token contract located on Common network, which is the right side of the bridge. And sometimes it works, sometimes it's not.
Live demo.
Yeah, live demo. Yeah, that's great. It's, yeah, we can see here, this transaction created. How can I understand this is the exact transaction I sent, right? If you remember when I sent it here, I used MetaMask, and on MetaMask I unlocked this account 0x2C57, right? And in Cohen we can see that that token is assigned to the same address. We use the same address on two sides of the bridge, and we can see this lots of boxes here. One of them is eventually our boxes. So that's how it works for cross-chain crowd sales. It's a new way of crowd sales, but also I think we should update our tool for the needs of people on one chain. So we have lots of improvements, and very, very open to help other people to run their crowd sales. So if you have any questions, you can ask them around.
Yeah, you wouldn't think. Anyway, those of us that are still engaged, not the people in the back, we don't need to think about that. Does anyone have any questions for you?
Yeah.
We just saw a live demo in cross-chain token sales. So.
Yeah, it's just fun. Just fun, like 15 seconds. Yeah, here's my friend Mo. We tried to participate at ETH Waterloo Hackathon, but Canada authorities didn't allow me to go, and so it's okay.
Yeah, so typically running a crowd sale, you have obviously the tech stack, which you're solving. How are you solving or maybe you're not, and that's fine. But how are you solving the legal aspect of that? So like, you can run a crowd sale, but you're not a legal entity in a particular place.
Can you repeat the question?
Yeah. So how we as a software solve problems with legal aspects of ICO? So we have two things. So we recreated Howitest as a wizard. So it's howie.oracles.org, and you can check if your token is security or not. It's not a legal advice. I cannot write this line, but at least it will give you some, yeah, let's just press this monkey test, right? Let's see if this monkey is security or not. And it's based on famous spreadsheet on Coinbase. So this, my token is unlikely is a scam. Well, and second thing, we have this, legal disclaimers that, when you use our tools, you understand what you're doing, and it's on you, not on us. We just provide software, how people use it, it's kind of not our problem. But for our crowd sale, we have legal opinion about our coin, and that's it.
So I didn't quite get the bridge thing. So if the transaction happens on one side, then the transaction also, another transaction happens on the other side of the bridge. So for each transaction is this way, and if it's so, how does this solve the scalability problem?
Okay, so bridge is one-way bridge, right? So if you want a two-way bridge, you have to set two bridges. So right now it's one-way bridge, like Bay Bridge. You can go, you can go from here to Auckland, on one lane, and back on another lane. And how it solves scalability issue? Right now you have 6.7 million gas every 15 seconds for the whole world, for 8 billion people, right? It's not enough. But if you move part of your token to one network, part of another network, and so forth, you can have your token located on multiple networks, and you can, for example, scale this computational world computer, as we call it here, right? It's not world computer now, but it can be if you can solve this scalability problem, which is second problem of the security problem, right? So that's my answer. And your question?
Yes. I read somewhere that to push market a token costs a few $100,000. Can you go over the different costs and address if your solution reduces the cost?
Of what? Of creating tokens?
Yeah, when you want to run an ICO.
Yeah. So price of running ICO using ICO Wizard is $0, 0 cents. We don't get anything from this. It's our contribution to the community. Why? Right? Why we are doing this? First of all, because we started this like a fun project on Meetup. Second, because you community, if you use it before us, you find some bugs and posts on features, and we were more sure about our tool, right? And third, we're building a community around our project because people who are using this tool, they're interested in what we are doing. And we have a story of one guy who created his mechanic. He fixed cars, right, somewhere in Massachusetts, and he tried to raise money on ICO Wizard on his software project, and he failed, right, because his project didn't get attention. And after he read about our network, he applied to be a validator. His long story about his 6 kids and wife and so forth. And he's applied for a notary license, and he will be validated on our network. For us, it's totally good because we accept any validator who can prove his identity and who can get his notary license. So for us, it's good because we get this community, we provide this tool, and also we build simplified tools so anyone can. It's one more approach to secure solution. If you have a secure way to create the ERC20 tokens, at least, using this wizard without coding skills, at least we can be sure that this part of ICO is secure and doesn't require additional audits.
Any more questions?
Yeah, just more. Can you share 20 seconds, 30 seconds story about bridge stuff?
Yes, so Igor is, if you guys don't know, he's a hackathon champ. He wins 1 out of 3 that he does. And so recently there was a Neat Waterloo hackathon, and I wasn't planning on going, and he had this idea to integrate this ICO wizard in with his bridge and try to make more usable scalable token for all these DApps that are out there. It's a lot of value. And he wasn't able to go because of a visa situation, so he asked like me and some other friends to try it. So last minute we ended up going, and just trying to deal with this bunch of different open source things and glue these things together and like resimulate the BAT ICO and launch a usable BAT token and integrate that in with like the new BAT wallet. They're one of the sponsors, and we kind of got it working, and then it all fell apart. We weren't going to submit it like this sucks. But we ended up just submitting it and going up there to show the part that did work. In the first presentation, we tried to click the button to launch it, and even that didn't work. And the whole thing didn't work at all. We thought we lost. But I guess the judges, and coincidentally Emmanuel was one of my judges, they liked the idea so much that they moved us forward to become finalists, even though we we're not working. But they wanted to do a code review to make sure.
Now it's working, I see.
Yeah, like to make sure that it took money needs to work afterwards, just to make sure that we did some work on it and like what we did and what existed beforehand. And so we like scrambled and we got our laptops together and we ended up to go through this code review. And the code review was Vitalik interrogating us about this hackup for like 10 minutes, just one-on-one, and giving us feedback and like ultimately like really just motivating us to continue to work on it and giving us like recommendations on what more to do and just trying to get more people involved and working on scaling. So we were going to go to DEFCON and they ended up going there and learning more about scaling and really trying to contribute back. So yeah, definitely stay active and contribute to open source projects.
So that's like what I want to finish with. Not this good. Yeah, so guys, we started Wizard as a toy project on a meetup. Then we started this bridge thing as a hackathon. So it's very easy to be helpful to this community. So you don't need some ninja skills to start this. And and if you're open to build something using Ethereum and Solidity, at least on our Silicon Valley Ethereum meetup where I'm a co-organizer, you can come and talk with us, and maybe we can help you to bootstrap your project. Well, if it's open source, right? Free and client side, this is things we love, and thank you for listening.
Everybody give it up for you.
Thank you so much, Igor. We really appreciate it. Awesome, guys. Well, we really appreciate your time and your attention. We hope that you learned some things. You were able to walk away knowing something that you didn't before. Hopefully something will be valuable in the future. We really appreciate you coming out to support the meetup. If you're still feeling at all hungry, please eat some pizza. We'll have a little bit of networking at, what's the bar, Matt?
Club 93. We'll also be giving away pizzas to people out on the streets.
Yeah, for sure.
Doing that.
Everyone is welcome to join us in giving away pizzas to people on the street on our way to Club 93, where we'll be hosting a networking reception. So thank you. Thank you so much for your time and attention.
Is that sitting there? I think I left that there.
Yes, no, go for it. Yeah, I thought it was just lost.